Hello, so I'm going to go through problem set 3-1 and 2. I don't have the problems on the screen, but hopefully you have them on your end, so that shouldn't be an issue. So first question has us finding the critical numbers of these two functions. Let's start with 1a. So we have g of x equals x minus square root of x. First step, to find the critical numbers, we're interested in the points or the values of x such that the derivative is equal to 0 or the derivative doesn't exist, right? And so we should first find the derivative, right? And to find the derivative, it would be best to rewrite this as a power. So the square root is a power of 1/2. And that means the derivative is equal to 1 minus 1/2 times x to the negative 1/2. And then we can rewrite that as 1 minus 1 over 2 root x, right? And so we're interested in where this equals 0. And so we're going to set this equal to 0. And then we can solve this. That's 1 over 2 root x equals 1, which means that we're looking at 2 root x equals 1 and trying to solve that. So root x equals 1/2 or x equals 1/4. And that would be our only critical number. Or actually, there's one more critical number, and that's where the derivative doesn't exist, and that would be also x equals 0. So I would say that would be an additional critical number. All right, so let's do the second one. Question B. We have g of t equals t root 4 minus t. Okay. So we should first find the derivative. Try to find the critical numbers. And to find the derivative of this, we can rewrite this as t times 4 minus t to the 1/2. For this, we have to use product rule and then chain rule as well. So first we're going to do product rule. So we're going to take the derivative of the first factor and leave the second one alone. That's going to be 4 minus t to the 1/2 because the derivative of t is 1. And then we're going to add t and then take the derivative of the second factor. So to take the derivative of the second factor, we have to use chain rule because we have a function on the inside and also a power of 1/2 on the outside. So we're going to first take the derivative of the outside function. It's going to give us 1/2, and then we're going to leave the inside alone. So 1/2 times 4 minus t to the power of negative 1/2. And then we have to take the derivative of the inside function here, and that's just negative 1. Okay? So if we were to rewrite this, we would have square root of 4 minus t minus 1/2 t. The negative 1 we can bring out as a minus sign. So 1/2 t times 1 over square root of 4 minus t, because the power of negative 1/2 is a reciprocal of a square root. Okay, and we're asking the question, where does this not equal to 0? Sorry, where does this equal to 0, and where is it undefined? So we also note in the question that t is less than 3. So that's kind of an interval that we're only looking at. And so when t is less than 3, there is no value of t that makes this undefined because the denominator here is always going to be a positive number. So we don't need to worry about undefined numbers. But there are going to be some values where this equals 0, right? So we should probably solve for those. So we could do 4 minus t, let's let it equal 0. And to solve this, we could move the 1/2 t times 1 over square root of 4 minus t to the right side. And then maybe now we could multiply both sides by square root of 4 minus t. And that would give us 4 minus t, right? We just multiply the left side by square root 4 minus t as well. That will give us 4 minus t equals 1/2 t. So if we solve this, we're going to have 3/2 t equals 4, or t equals 8/3. Okay? Let me just check my answer here. Yeah, looks about right. Okay. Let's do 2a now. Finding the absolute extrema of the functions on the closed interval. So that's going to require us to first find the critical numbers, and then to test the critical numbers and the endpoints at the function, and see which one's the maximum and the minimum. So we first question, we have f of x equals x cubed minus 3x squared on the interval -1, 2. And so, if we take the derivative to find the critical numbers, we have f prime of x equals 3x squared minus 6x. And so that's always defined. So we're going to look for which values make this equal to 0, and those will be critical numbers. So if we factor this, remember not to divide by x, you have to factor it out. If we factor, we get 3x times x minus 2, 0. And so critical numbers are going to be x equals 0 and also x equals 2, which also happens to be an endpoint, right? And so now we're going to evaluate the function at both the endpoints and also the critical numbers. So f of -1, don't forget we're plugging it into the original function, not the derivative. F of -1 is -1 minus 3, which is -4. F of 0 is going to be 0. And f of 2 is 8 minus 12, or -4. Right? And so out of these, we have a double minimum and then one maximum. Okay, so this is a minimum. This is a maximum. This is a minimum. All right, let me check this. Yeah. All right, let's do part B. Okay, we have h of t equals t over t plus 3 on the interval -1, 6. So first we're going to find the derivative. That's going to be, we're going to have to use quotient rule here. Low d high minus high d low, or low squared. So that's going to come out to t plus 3 minus t on the numerator. All right. So does this ever equal 0? The answer is no. And so we're looking for where this is undefined. And that would be at t equals -3. Okay? But this is not in the interval, right? -3 is smaller than -1. And so within the interval, there's actually no critical numbers. And so that means there are no critical numbers that we're interested in, and we should just test the endpoints. That's it. So we're just going to plug in h of -1 is -1 over 2, -1/2. And then h of 6 is going to be 6 over 9, which is 2/3. So this will be our minimum, and this will be our maximum. Okay. Do question C. It's a little harder because we have trig, which you guys probably haven't done in a while. So we are looking at y equals 3 cosine x in the interval 0, 2 pi. All right, so first we're going to define the derivative. So y prime equals negative 3 sine x. This is always defined, but when does it equal 0 within this interval, right? 0 to 2 pi. We could probably look at the unit circle. When does sine equal 0? Well, sine will equal 0 whenever the y coordinate on the unit circle is 0. So that's here, right? And that's 0, and that's pi, and that's also 2 pi, right? And that'll be all the critical numbers within the interval between 0 to 2 pi inclusive. And so our critical numbers are going to be 0, pi, and 2 pi. Conveniently, both of our endpoints are also included, right? So we don't need to worry about those. Okay, so y of 0 is going to be 3 times cosine 0, which is 3. Y of pi is going to be 3 times cosine pi, which is negative 3. And then y of 2 pi is going to be 3 times cosine 2 pi, which is 3. This is a maximum, so we have a double maximum, and we have a minimum. Okay? This is not hard to see from the graph of cosine. If you graphed cosine, you would have gotten, right, between 0 and 2 pi, would have looked like this. So that's exactly what we expect. Let's do question 3. Okay, so we have to first determine whether the mean value theorem can be applied. And that's if it's both continuous and differentiable within the interval. And then we're going to find which values of c in the interval make that derivative equal to the slope of the endpoints, the slope of the line that connects the endpoints. So for the first function, we have f of x equals x cubed plus 2x plus 4, right? And so that's obviously continuous. We know this is just a polynomial. And it's also differentiable, right? Because when we find the derivative, it exists everywhere. Derivative is 3x squared plus 2. So mean value theorem can be applied. So we will say yes, can be applied. And then now we're just going to look for which values of c make that derivative equal to f of b minus f of a over b minus a. So, right, first f of b minus f of a over b minus a is equal to, right, in this case, b is equal to 0 and a is equal to negative 1. And so f of 0 minus f of negative 1 over 0 minus negative 1, which is 1, right? And so f of 0 is 4 minus f of negative 1, which is negative 1 cubed, which is negative 1, minus 2 plus 4. So that's going to be negative 3 plus 4, which is 1. So I'm left with this equals 3. Okay, so now we're trying to solve f prime of x equals 3. So that means 3x squared plus 2, right? We're looking for those values of the derivative that equal 3. So 3x squared plus 2 equals 3, which means that x squared equals 1/3, or x equals plus or minus root 3 over 3. And then the final answer is actually only going to be negative root 3 over 3. Because positive root 3 over 3 is outside the interval. Question B, we have f of x equals x plus 2 over x minus 1 on the interval -3, 3. So first we need to ask whether mean value theorem can be applied. And the answer is actually no, because this is not continuous within the interval. And we would say no, because there is a discontinuity at x equals 1, right? That makes the derivative, the denominator equals 0, which makes the function undefined. And 1 is actually within this interval, so that means mean value theorem cannot be applied. C, we have f of x equals x over x minus 5 within the interval 1, 4. This also has a discontinuity at x equals 5, right? But in this particular case, x equals 5. X equals 5, which means that that's actually outside the interval, right? Which means that I'm recording a video. That's why I should. And so, sorry for the interruption. The discontinuity is at, sorry, I'm not even going to write it. The discontinuity in the original function is at x equals 5, which is outside the interval. So that's not a concern. And so next we should find the derivative, see if that exists, because it also has to be differentiable, right? So the derivative, we're going to do chain rule, low d high, x minus 5 times 1, minus high d low, x times 1, over x minus 5 squared, which is equal to x minus 5 minus x, so it's negative 5 over x minus 5 squared. Okay, and so that also has a discontinuity at x equals 5, which is once again outside the interval. And so, yes, mean value theorem can be applied. And then we're going to try to find f of b minus f of a over b minus a, which is equal to, let's see, b is equal to 4, right? So that's 4 over 4 minus 5, minus a is 1, so that's 1 over 1 minus 5, over b minus a, which is 3, 4 minus 1. So that's negative 4 plus 1/4, because that's minus 1 over negative 4, so it's plus 1/4 over 3, which is equal to negative 15 over 4 over 3, which is equal to negative 5/4. Okay, so we're going to try to solve. All right, this is what the question is ultimately asking. Trying to solve f prime of x equals negative 5/4. So we have negative 5 over x minus 5 squared equals negative 5/4. We can pretty much just look at this and see that x minus 5 squared has to equal 4, right? Which means that x minus 5 equals plus or minus 2. Don't forget the plus or minus, very important. And so x equals 5 plus or minus 2. Now, which one of those values, right? That's going to be or 3 and 7. Now, which one of those values is within the interval that we care about? Only 3 is going to be within that interval, right? So x equals 3 is going to be our final answer, because this is outside the interval, 1, 4. Okay, that concludes the video. Hopefully it's helpful.